If we're going to study trigonometry, we might as well have some idea as to why we're studying trigonometry. So let's take a look at some applications of right triangle trigonometry. One application that's kind of cool, and there are many, is this one here, where you want to take a picture of the Eiffel Tower. You'd like to get the entire Eiffel Tower in the photograph. It turns out that every camera has something that's called an angle of view or a field of view. In other words, you can only see the camera can only see so much. And the height of the Eiffel Tower is well known. You can look it up, and it's on the internet. But first, let's take a quick look at this idea of field of view. If we go to Wikipedia and we look up field of view, we can see that it's kind of well known that cameras have a certain angle of view. In our particular application for the Eiffel Tower in the picture, the angle is 42 degrees, and the height of the Eiffel Tower again is well known. It is 324 meters tall. So what we'd like to know is we'd like to know how far away do we need to be from the Eiffel Tower in order to get the entire Eiffel Tower in our view. And somebody did a real neat thing for us. They made this little animation where we can move the camera forward and backwards, and we can actually see what the camera sees over here. So what we'd like is we'd like to get to the point where the camera has the entire Eiffel Tower in the view. If we go too far away, we're missing details of the Eiffel Tower, and if we get too close, then we don't get to see the entire Eiffel Tower. So we'd like to know what's the optimal distance here. So again, our angle of view is 42 degrees with our camera. By the way, this also has a fancy name called the angle of elevation, and maybe we should write that down and add that to our notes. We'll see that again, but this guy right here, this guy's known as the angle of elevation, and we'll see that in other word problems, but it'd be nice if you knew the definition. So that's called the angle of elevation. Let me go ahead and get rid of that, clean up the drawing a smidgen. Okay. Anyways, the angle of elevation is 42 degrees. The height of the Eiffel Tower is known to be 324 meters, and we'd like to know x. I mean, isn't that, after all, what algebra students for all time have been seeking? We always want to find x. So anyways, here, as usual, we'd like to find x. So it turns out if we know the angle of view for the camera, and we know the height of the Eiffel Tower, we can figure out exactly how far we need to be away. By the way, my x drawing's a little bit off, isn't it? I just noticed that maybe we could actually, yeah, we kind of want to go like to the center of the Eiffel Tower. Sorry. Anyways, we want to know the distance from the Eiffel Tower. The way we'll do that is we'll use a trig ratio. But what I'd like for you folks to take a moment and see if you can set up the appropriate trig ratio. I want you to quiz yourself right now. Should we use sine or cosine or tangent? And then I'd like you to set it up and try to do the math. And you're going to pause your video right now. And then in a minute, we're going to check together to see if we agree on how the problem should be set up. Okay, we're back. So let's go ahead. Let's try to do some math and see how this works out. So first of all, I'm thinking that because we know the opposite side and we want to find the adjacent side, I'm thinking we should use TOA, or tangent. So what we say is that the tangent of the angle, in this case 42 degrees, should be equal to the opposite side, 324, over the adjacent side, which is x. And then if we want to then figure out what x is, we got to get x all by itself. And I'm going to show you a neat little trick. I don't know if you've seen this before, but what we're going to do is this, is we're just going to swap the x in the tangent of 42. It is a time-saving technique. You would get the same exact result if you did cross multiplication and then solved for x. I just wanted you to know that there's this neat little technique that gets us the result a little bit more quickly. So if we then knew how to put tangent of 42 into our calculator, we could then go ahead and calculate what x is. Today we're not going to. All I wanted to do was show you a practical application of trigonometry and take a look at how to use the tangent trig ratio in order to find x. I only have this one additional application that I want to show you right now. I didn't want to make this video too long. And what I wanted to show you was that trigonometry is really used in the world all around us. Every day you're using it whether you know it or not. It turns out that this thing called GPS, the thing that you or your parents use to find out where you are when you're driving and where you're going, all of that's dependent on trigonometry. We have satellites that are up in the sky above the Earth, and we usually need at least three. If three of them are sending signals down and our phone can receive signals from three of those guys, what happens is there are triangles that are constructed, and the triangles on the phone, what happens is the satellites tell the phone what position in the sky they're at. And then the phone does the math to figure out that if one satellite's here and another satellite's here and another satellite's here, then you must be at such and such location on the Earth. Now, I don't want to go into great detail about the math related to GPS trigonometry right now, but I at least wanted to show you one additional application of trig besides the Eiffel Tower and the camera.